Broadcasting live. It's America's longest running talk show on computers. It's Computer America, bringing you the biggest names in technology with guest interviews, new products, and your emails. Listen live at computeramerica.com on any device around the world. Email the show at live@computeramerica.com or find us on social media. Be sure to check out our website for contests, giveaways, show notes, live video stream, podcasts, and more. You're listening to Computer America.
Hello and welcome everyone into the Computer America Show. We are the nation's longest running nationally syndicated radio talk show on computers and technology turned podcast, and everyone welcome to the program. I hope that you're doing well, and I give you a little chuckle there at the beginning because if you remember the feeling of going to class and not having studied right before a big test, for today's show notes, I was kind of reading through, and let's just say our lead article has to do with Majorana, quasi-particles, and topological qubits. That feeling crept up in me very strongly. But ladies and gentlemen, we have someone here with us who's going to break it down as best he can, as best we can, and we're going to try to get through some of these stories that you may have missed. So today on the show, we have the one, the only Mr. Ralph Bond. He will be joining us here. He is our science and tech trends correspondent, and we are going to talk about a number of stories that are going to be a little bit, on the less mainstream side, more research side, and just kind of the fun, cool side, because really, it's hard to think of a better show to lead out on a Friday than the ones with Ralph. So with that being said, computeramerica.com, that's where you'll find everything, including the show notes, and within the show notes, links to articles and research papers, and anything that we talk about will be included there at our site. So if you get confused, and that would never happen, but if you get confused or you want to check up on anything, hey, computeramerica.com is all you really need to know. So with that being said, let's go ahead, bring on Ralph. I hope everyone out there has had a great, week since last time we had Ralph on, and we are ready for, a really, really fun and hopefully uplifting show. So with that being said, Ralph, welcome back onto the program. How you been?
It's great to be back, and believe me, in this crazy news world we're living in right now, we need uplifting news from science. And by the way, folks, if you're new to the show, what Ben and I do each Friday is highlight 4 recent articles that show us key trends in developments in artificial intelligence, robotics, medical technology, sustainable energy technology, transportation advances, agricultural tech, space research, physics, you name it. And most important of all, as I just alluded to a moment ago, we're going to give you an oasis. It's Friday. I'm having trouble with that word. An oasis of positive news thanks to the world of science and technology.
Absolutely. And I think you picked out 4 amazing stories. They're going to be everything from, biomedical tech to, some AI in there. You can't get away from AI. It's going to be everywhere. And really, like I was kind of alluding to in the first story, the extreme being the ever confusing quantum computers. So I think we'll start, ladies and gentlemen, with story number 1. And, ever since we've had, IBM on the show and some of their lead, like Ralph, of all the interviews I've ever done over, however many years I've been doing this, I've never felt more like a child talking to an adult than, because sometimes you have people on the show, it's like, oh, you make, dedicated websites for loved ones after they pass so that, they're essentially like digital gravestones. And, that's a very cool idea. Like, you kind of get the idea. You get, you get printers from Epson, you get, products that are pretty easy to grasp. But then you get on the lead scientist that led the IBM quantum computer research. And I was like, oh, could you explain that, and that, just so we can understand the one sentence that you kind of led off with? It's a very confusing topic, and I hope that, the article does a good job and we can kind of do a good job of breaking it down. But quantum computers, they're amazing. They're going to do things that are going to help us a lot in the long run, but we have some major issues to tackle. And looks like story number 1 might be one of those, as the title kind of says itself, a breakthrough to that. So yeah, let's start.
Yeah, this is really interesting stuff. The first time I saw this headline was from Popular Mechanics, and the headline was, "This chip could be the massive breakthrough we've been waiting for in quantum computing," which certainly is a very enticing headline.
Hmm.
And immediately I found lots and lots of other references to this. And folks, come out and get the show notes at computeramerica.com so you can get these links. We're talking about a chip that, of all people, Microsoft has developed. I mean, when you think about chip development, you think of NVIDIA or you think about Intel or what, Microsoft. Wow, this is something else. And it's in this world of quantum mechanics or quantum computing, as we'll explain in a moment. But get out to the show notes because we've got a lot of great stuff, including Microsoft's video about this as well, which is good, and several other references. So first, let's set the stage with a reminder, which kind of goes back to what Ben was just saying a moment ago. The world of quantum mechanics, quantum physics, quantum computing is mind-meltingly bizarre and so hard to wrap your head around. So I'm not going to claim to be an expert on this at all. I'm a layperson student in awe, kneeling before the altar of brilliant people that I'll never be able to match. But with that said, a little reminder here, a quantum computer is a type of computer that uses the principles of quantum mechanics to perform calculations. Now, unlike classical computers, which use bits as the smallest unit of information with simple values of either 0 or 1, on or off, quantum computers use quantum bits, or what they call qubits. And qubits, here's where it gets really weird. Qubits can represent both 0 and 1 simultaneously, thanks to a property called superposition. And if you want your brain to melt and go down the drain, start studying this stuff and you'd be awestruck. So as my show notes indicate very clearly in bold type, red color type, this is very geeky stuff. And the key points to the Popular Science article and other supplemental information I injected into the show notes are going to be provided below in the show notes. But what I'm going to do to try to crunch this down and make it as quick and simple as possible is I went out to Microsoft's artificial intelligence Copilot and asked, what's the deal with this Margiana 1 chip? And by the way, there's 5 or 6 different ways to pronounce the name of this thing. Majorana is easier to say, so I'm going to go with that. So you can come back to the show notes and get more of the details, but I'm going to give you the rundown that Copilot gave me. So first of all, the Majorana 1 chip is a big step forward in quantum computing, which is a new type of computing that can solve very complex problems much faster than regular computers. And hey, you might be thinking, well, why the name Majorana or Magiana, or the different ways to pronounce it? Side note about the chip's name. Microsoft's new quantum chip is called Majorana 1 because it's based on a particle known as Majorana fermion, Fermion. This particle has the unique property of being both matter and antimatter. What?
Like,
this is so weird, Ben.
Every time like you get into quantum computers, like the very basics of it, like you kind of let off with where it could be 0 or 1 simultaneously. It's okay, 2 values, and maybe sometimes it could be 3. Yes and no. And then they're like, what would make it a little bit more confusing? Let's throw in matter, antimatter. Like, just it seems like every principle of like the quantum world and like all the really weird stuff plays a role in what they're trying to do, and it's crazy.
It is absolutely. It seems completely counter logical. We live in a binary kind of world day to day. You get into quantum mechanics and quantum computing and so forth, it's a whole other reality almost in a way. It's bizarre. So going on with the distillation that Copilot gave me, the new chip uses a special kind of qubit, the basic unit of quantum information, called topological qubits. Now, I've heard of qubits, but I never heard of topological qubits. These are more stable and less prone to errors, making the chip more reliable. And the chip can potentially support up to 1 million qubits on a single chip, which is a huge improvement over current quantum computers. Now, Ben, you remember back in January, on our January 31 show, we talked about a company called Equal One, which claims it's developed a way to create quantum processing chips using conventional semiconductor manufacturing methods. And they further claim to say Their new chip can operate at ultra low temperatures and paves the way for millions of qubits on a single chip. So salute to Microsoft for what they're doing. I'm not saying they're on the wrong path or anything, and they're not claiming to be the one and only guys out there trying to get millions of qubits on a single chip. Just a fairness notation here that a salute to Equal One, because we did talk about them in January.
Yeah, it's all research, and claiming that the theoretical maximum possible is millions, and then Microsoft saying, that we can put 1 million qubits on a single chip as well. Neither of them have done it, but both of them say the math works out that they can do it. So it's still very early on. I'm sure someone else, Ralph, next week is going to come out. Google's going to come out with their own chip that's going to be equally as impressive. It's a very the field is very hot right now.
Oh boy, scalding hot. Yeah. And the Microsoft Majorana 1 chip, and here's where it gets even weirder, folks, is powered by a new state of matter called topological superconductivity, which helps in creating and controlling the qubits. New state of matter. How much weirder could this get? But bringing it back to reality, what are some of the real world applications this technology breakthrough and other quantum computers of this type could bring to us if you can get millions of qubits on a chip? If you can do that, this technology could revolutionize various fields like medicine, science, and environmental solutions by solving problems that are currently impossible for regular computers. That's this threshold we're on right now, folks. Artificial intelligence in this century has been just this deal-breaking turning point. Now, when you bring in quantum computing, we're also at kind of what Andy Grove at Intel used to say, a strategic inflection point.
Exactly. Yeah. It's important to remember that, it's not like quantum computers are going to be what you're going to be browsing the internet on. You're not going to be playing your next video game on. It's not like, a more powerful graphics card or something like that on your computer. It's more like it can do calculations that, Ralph, with our zeros and ones would be, you can imagine if it was just like a long string of zeros and ones of calculations and outputs and inputs, would be miles and miles long. And then a quantum computer, instead of having that one lane road, it has tons of branching roads and, like a city, just roads interconnecting, and you need a lot less space. It would just be, yards and yards of road essentially instead of miles of a single lane road, but you get to the same destination. So, it's not more powerful. It's just kind of different and can do certain things better. But it's not going to completely replace your laptop at home. So just want to make that clear to people.
Yeah, that's a good point, Ben. And in the show notes, again, if you want to geek out, I've got now in the show notes, you can look at the highlights from the it's Friday, Popular Mechanics article. You can get all those details. And of course, the link to the full article if you want. And then I injected some additional background on the Majorana 1 chip and the topological qubits. More geeky stuff. Come out to the show notes if you want to dive deep into that and have fun with it. But it is weird stuff.
No, and I think that's a good way to kind of wrap up that article, because there's still obviously so much more to talk about that article. But Ralph, it's incredible that and the fact that Microsoft, like, no offense to Equal One, these smaller companies that do, and there's no shame in being called smaller than Microsoft, because I think most people are, smaller than Microsoft. But smaller companies doing innovative research, always necessary and will always be, cutting edge. But the fact that Microsoft is the one coming out and saying, hey, we've made a really big leap, that has weight and value in it as well. It's not just, someone with a research paper and a grant. No, it's Microsoft. So that's also very cool. So very nice story, one, Ralph. And ladies and gentlemen, there's even more. Again, there were the highlights from the article itself, and there were, some more background that Ralph had included. If you want to check those out, check out the show notes. It will all be included in there as well. So still a lot more to go over that. But Ralph, if you don't mind, I think we're going to skip on over story number 2 and give our brains a little bit of a break, because going from the quantum world, which they threw in like superposition, they threw in superconductivity, they threw in terms that I don't think needed to be there, but I don't even know. Story number 2 should bring us a little bit back down to earth because it's, once again, scientists trying to recreate what nature does best, and this time with an artificial leaf. So, story number 2.
Yeah, this is a good one from futurism.com, a wonderful, wonderful outlet, by the way. Headline: Scientists reveal artificial leaf that turns carbon into sustainable fuels. And again, we have the link, and we have the link to their research paper and so on. And start off with my comment about this. A trend I'm seeing, and Ben, you, of course, together with me, we've been seeing this more and more, is research to imitate photosynthesis to produce interesting results, and I'll add products. And this story really fits that bill in terms of a trend. So using an ingenious method inspired by photosynthesis of living things, scientists at the University of Cambridge and the University of California, Berkeley, wow, that's wonderful, a US and UK collaboration, have developed a new artificial leaf that removes CO2 from the air and turns it into sustainable fuels and other products, I should add. And for years, and this is the important point here, this is not the first time. For years, scientists at various institutions have experimented with similar artificial leaves that can absorb light and CO2 in similar ways to the real thing, meaning the leaves and so forth in nature. But now, researchers at the University of Cambridge and the University of California, Berkeley, have designed a system that uses the nature-inspired technology, again, photosynthesis, alongside microscopic copper nanoflowers. What the heck? We'll find out. To create cleaner hydrocarbons, which, like fossil fuels, are derived from hydrogen and carbon. And you might be saying, Ben, what the heck is a copper nanoflower? Well, they are tiny flower-shaped structures made of copper at the nanoscale. And these fascinating structures have unique properties and applications, particularly in the field of clean energy and chemical production. Already I think we're coming back to reality from the world of quantum computing, but this is still pretty weird.
It's still the science of the small, and they have some 3D images of what these copper nanoflowers can essentially look
Yes.
like. But yeah, it's Ralph. It's the natural evolution of solar panels. They're pretty commonplace nowadays. And what is the most efficient solar panel out there? And oddly enough, I think the answer is probably Mother Nature, leaves and trees and whatnot. They're very efficient with very little, putting into it. So obviously, science is trying to imitate, replicate, and improve on what nature does, naturally.
Yeah,
so
absolutely right. And going on, it says here, in a recent published paper, and again, we have a link to that paper in the show notes, the scientists detailed how they built on prior Cambridge research into artificial leaves made with perovskite. Sound familiar? That's the crystalline compound that might make solar panels cheaper and more efficient in the future. Perovskite is really interesting, guys. This, in the world of solar panels and so forth, is one of the things that researchers around the world are racing to implement because it will improve solar panels immensely. But again, this solution that the Cambridge and UC Berkeley folks came up with uses artificial leaves made with this perovskite material. And despite their success in making carbon scrubbing artificial leaves in the past, meaning artificial leaves that could absorb CO2 from the air, a Cambridge chemist and the paper's lead author said that he and his fellow researchers wanted to take the technology further. So they had done some work before with artificial leaves, but they wanted to go further. He says, quote, "We wanted to go beyond basic carbon dioxide reduction, that is absorption, and produce more complex hydrocarbons output." He said in the school's press release, but that requires significantly more energy. So that's the challenge they gave to themselves. And to make this happen, the Berkeley and Cambridge scientists used the light absorption power of perovskite-based artificial leaves and the copper nanoflower as a catalyst to synthesize complex hydrocarbons like ethane and ethylene with just CO2 and water. Now, remember a moment ago we said the problem was converting the CO2 captured through an artificial leaf back before this breakthrough would require a lot of energy. They're talking about pulling this off and producing complex hydrocarbons like ethane and ethylene with just CO2 and water. Just CO2 and water. Let that sort of sink in for a second. Pretty cool stuff, my Ben.
Yeah, it seems like another key trend, and I'm sure this is just science in general, and I'm just 100 or 1,000 years late to the science party, but it seems like, Ralph, a lot of these stories, some of the breakthroughs aren't even like a fundamental change. It's just, let's say something takes 4 or 5 steps to get from where you start to where you want to go. Cutting out one of those 5 steps and combining it with step 2, so you just take out step 3 completely. We had an article a couple of weeks ago about taking out like the heat and the need to like smelt stuff, and turn it into like recyclables. Like, just cutting out one of the steps is a huge breakthrough. Not that you really do anything fundamentally different with the end product or the beginning, but shortening the process is a huge improvement, which seems like what they're trying to do here as well.
Yeah, absolutely. And going on here, it says the researchers then tacked onto their device some electrodes made of silicon nanowire, which allowed them to add in the chemical compound glycerol and make their device a reported 200 times more efficient and produce valuable chemical byproducts like glycerate, lactate, and formate. And now, in the show notes, if you want to find out what those 3 things are, I've got additional information. We're not going to take time now to drill through this, but the point of it is those 3 things are very valuable to the world of production, medicine, all kinds of things across the board. You can find out about that and in the show notes. So check that out. That's really worth doing. And so with that kind of wraps this one up. Again, artificial leaf, pulling CO2 from the air. They found a much less energy intensive way to then convert that into useful products.
Yep, and the useful products, like you said, full list in the show notes, but it looks like it's going to touch everything from pharmaceuticals, textiles, biodiesel, cosmetics, leather, oil and gas, detergents. Ladies and gentlemen, just a few things that some of us use only occasionally. So there you go. Very cool. And again, love the collaborations between universities. Always like to see that. Sorry. So with that being said, story number 2, story number 3, we're going to go ahead and jump on down, and we're going to talk a bit about AI. Just before the show, we were talking about making some changes that AI might play a role in our accessibility for the show, because Ralph does an amazing job with the show notes. We might have live captions on the screen, stuff like that. Just some simple things that live captions wasn't really working too well in my experience, but now maybe something that we're going to add to the show here in the near future. Some of the improvements that AI can do, and AI is working its way into a lot of facets of your life. So hopefully for the better. Again, we're hopeful. We're on a Friday. This is going to be good. So we're on a hopeful binge. So with that, story number 3, AI getting into everything, looks like it's getting into, and I like the idea that they had in this of like the reverse process where like scientists had an idea of what they wanted, and then they told AI, get to this endpoint. We don't know where you're going to start, but get to this endpoint. And came out with this really fun article about AI design chips. So, Ralph.
Yes, this is really good, from livescience.com. And friends, we started off the show in the world of weird. We're coming back into weirdness for a bit here, but this just is, to me, is absolutely fascinating, having spent a large part of my career in the semiconductor industry, with beginning with Rockwell Semiconductors and then Intel and all that. Fine. Headline: artificial intelligence designed chips are so weird that humans cannot really understand them, but they perform better than anything we've created. What a headline, right? Again, livescience.com. Show notes have all the links, all that good stuff. We have a link to their research paper, too, if you super want to geek out. But here we go. Engineering researchers at Princeton Engineering and the Indian Institute of Technology have demonstrated that artificial intelligence can design complex wireless chips in hours, a feat that would have taken humans weeks to complete. But there's more. Again, talk about like, collaboration, Ben. This is great. Princeton and the Indian Institute of Technology.
I feel like that that's a very generous article to be like, oh, it took the AI hours. I understand. It took it would have taken humans weeks to complete. I think I still would have been working on this. I think it's very dependent on which humans you pick, because if you pick like 10 bends, it would have never gotten to where AI got it. Weeks, months, years. That's all I'm saying. So yeah, dependent on the human.
Yeah, that's true. And this gets even more interesting. But by the way, it talks about wireless chips. Well, what are we talking about? Wireless chips, also known as wireless communication chips or radio frequency chips, are integrated circuits that enable devices to connect and communicate without physical wires. Of course, they use electromagnetic waves to transmit data over the air. And you might be going, okay, so what? Well, wait a minute. These chips are found in a variety of devices, such as smartphones, laptops, routers, and Internet of Things devices. So that's what we're talking about. Very important chips. And we're talking about what happens if you ask AI to design a chip for this purpose. So going on with the story here, it says not only did the chip designs prove more efficient, the artificial intelligence took a radically different approach, one that a human circuit designer would have been highly unlikely to devise. So I'm going to do a little quick timeout here. If you, in a kind of building on something you were alluding to a moment ago, Ben, a human being would go, or a team of humans would go, well, we know we want to achieve this result. We have a history of this building block working, and combined with that building block works. We know that works. How can we improve it? Maybe if we try this, modifying those building blocks, we might be able to achieve our goal. And so it was building on known history, known building blocks. What you're going to find out in this article is artificial intelligence took a different path. The researchers said to the AI, large language model and database and so forth, this is what we want in the end. Go make it happen. So the AI had no preconceived ideas.
Yeah.
That's the thing to grab on and hold on to.
Yeah, it's I won't use video game studios, but you can imagine like like let's say movie producers like Pixar's versus DreamWorks versus whatever other animation studio you may have. And Ralph, like they have their design process, they have their general. Here's how we start with our characters. Here's how we what I mean, Ralph. Like you can kind of see a DreamWorks picture and you can kind of go, hey, that looks a little bit like Toy Story, or that looks like Monsters Inc. Like they generally kind of design their characters in a way. And I think humans have that same bias where, oh, this is how a chip is kind of set up. Here's how you kind of have those preconceived, those routines and biases that you kind of start with. But I guess AI is just like, they don't have that. They're not innately in there.
Yeah, the ultimate example of thinking out of the box. But going on here, it says the research of this team focused on millimeter wave wireless chips, which present some of the biggest challenges facing manufacturers due to their complexity and need for miniaturization. These chips are used in 5G modems, now commonly found in phones. So we're talking about designing chips for very real world applications. All of us pretty much now have smartphones, right? So manufacturers currently rely on a mix of human expertise, bespoke circuit designs, and established templates. This is what we were talking about, known building blocks, right? Yep. So here we go. Each new design then goes through a slow process, traditionally, of optimization based on trial and error, because it's often so complex that a human cannot fully understand what is happening inside the chip. This leads to a cautious, iterative approach based on what has worked before, everything we were building up to so far, Ben. But in this case, however, researchers at Princeton Engineering and the Indian Institute of Technology posited that deep learning-based AI models could use an inverse design method, one that specifies the desired output and leaves the algorithm to determine the inputs and parameters. Oh, it's entirely different. It's like go to the end and come back.
I definitely like it. The inverse design method.
Yeah.
I guess that's very similar to just reverse engineering. You know what you got, and now you got to break it down. So
yeah. So the AI also considers each chip a single artifact rather than a collection of existing elements that need to be combined. That was my building blocks discussion. This means that established chip design templates, the ones that no one understands but probably hide inefficiencies, are cast aside. In this experiment, the resulting structures, quote, look randomly shaped, said the lead author of the team's research paper. Humans cannot really understand them. And get this, Ben, when the team manufactured the chips based on the design the AI came back with, they found the AI creations hit performance levels beyond those of existing designs. And further, they also talk about how weird they are, how weird they look, and so forth. But hey, they work, and they work better than traditional existing designs for these wireless chips.
Yeah, I wanted to real quick, and I think this might be the best one that I have. Let's see if I can open this in a new tab, drag it over to the video portion, which, ladies and gentlemen, you should check out. This, I guess, would be a typical 5G chip if Google is worth its weight. And this is what the AI kind of designed, and it looks... man, a way throwback. Ralph, do you remember Space Invaders, the video game?
Sure, of course.
Yeah, and do you remember what like the barriers kind of look like after a game or after a round of Space Invaders, where they're all chipped away and kind of broken apart?
Yes.
After that's what essentially the AI kind of came up with. It is messy. It is just all over the place. It looks like Detroit. It is just a disaster. No, I'm joking. But this is what humans make, which is just a nice uniform block with all the little
That's
pins
a good
there.
Comparison.
So it Ralph, like if you look at that and tell me which one's more efficient, I would obviously say the more, to my human brain, the more evenly spaced, patterned, pleasing to look at one. But AI says this is better, and looks like the research backs it up. It's crazy.
Isn't that something? It really is something. And again, the researchers stress they don't really fully understand it, but hey, great, it works. Go for it.
If it works, it works. So there you go. And I think that's a lot of AI. If it works, it works. So there you go. Story number 3. Story number 4. Let's go ahead and get back to, if the first one was really out there, story number 2 was about leaves. Story number 3, really out there. Story number 4, medical, which, is something that Ralph definitely tries to highlight, because the field of medicine is always evolving and, is very much worth paying attention to, because Ralph, speaking of like reverse engineering from the previous article, we know a lot of the problems. People, get serious injuries, they have serious diseases, they have serious problems. We know the problem. Finding a solution, that's where the research comes in, and they do an amazing job. So,
yes.
Yeah, so story number 4, hey, could help people who, maybe need a, dare I say, helping hand. So, yeah, story number 4.
Yeah, and if you're a longtime participant with the show, you know that we typically try to end our Friday segments with a story that has something to do with medical technology research. This one is kind of interesting, Ben, because you could say it's in the field of prosthetics, but it's also possibly maybe going to have something to do with robotics as well. But let's get into the story. This comes from a press release from the University of Tokyo, and this got a lot of coverage in the scientific news community. But I went right to the source, to the Tokyo press release. And the headline here is Biohybrid Hand Gestures with Human Muscles, Complex Finger Movements Made Possible with Rolls of Tendon-like Human Muscle Tissue. Wow. So we're talking about lab-grown human muscle tissue. We're talking about combining it with robotics, with the eye toward prosthetics. I mean, what's not to love about this story? And we've got links, and we've got a video in the show notes, links to that, and good illustrations. But let's get into this. A biohybrid hand, which can move objects and do a scissor gesture, has been built by a team at the University of Tokyo and Waseda University in Japan. I hope I'm saying that correctly. The researchers used thin strings of lab-grown muscle tissue bundled into sushi-like rolls, I love that, to give the fingers enough strength to contract. Wow, we're going to find out why this technique is so important. These multiple muscle tissue actuators created by the researchers are a major development toward building larger biohybrid limbs. This is just the start. While currently limited to the lab environment, So we're talking about twinkle in the eye research here, folks, early research. While currently limited to the lab environment, multiple muscle tissue actuators have the potential to advance future biohybrid prosthetics, aid drug testing on muscle tissue, and broaden the potential of biohybrid robotics to mimic real life forms. So if you think about this research having impact, wow, that sentence right there says it all.
It's not too far back that we look and we say, okay, we were just making muscle tissue in general, from stem cells and whatnot, and now we're not just making the cells, but as I said, the actual fibers, and and I think that's the really cool part, because looking at the video again, which is just like a little 10-second kind of gif, but you could see just barely the strands, the strings right there has a little bit of bubble on it. That's muscle fiber. That's crazy.
I know. It's also weird. It's like Terminator movies becoming real. It's just so incredible.
Yeah.
So the robot hand has mastered the art of the scissor gesture, and while it might seem like a simple motion in the realm of biohybrids and prosthetic limbs, this is a leap forward towards new levels of realism and usability. And the hand is made of a 3D printed plastic base with tendons of human muscle tissue which move the fingers. Now, let's talk about the problem this team faced. Thick muscle tissue, which is needed to move larger limbs, is difficult to grow in the lab as it suffers from necrosis. I hope I'm saying that right. And this is when insufficient nutrients reach the center of the muscle, resulting in tissue loss. However, using multiple thin muscle tissues bundled together to act as one larger muscle, the team was able to create tendons with enough strength. Think of it like rope, where you have multiple twine wrapped together or knit together, as it were. That's kind of what's going on here. And the multiple muscle tissue actuators are stimulated using electrical currents delivered through waterproof cables. Wow. And then, Ben, to test the abilities of the hand, the team manipulated the fingers to form a scissor gesture by contracting the little finger, ring finger, and thumb. And in the world of artificial or prosthetic hands, this is quite an achievement. They used the fingers to grasp and move the tip of a pipette. A pipette's a liquid transfer device in laboratories. And this demonstrated the hand's ability to mimic a range of actions, as the multi-jointed fingers can be flexed either separately or at the same time. Again, a very impressive feat. So, wow, in the world of prosthetics, it just keeps marching on every minute of every day. A story like this, I think, to me at least, really highlights the the struggles, because Ralph, like, I don't know, as someone who is not totally immersed in this, we get our snippets that we do here on the show, but it's like, oh, just make a hand. We've seen bigger prosthetics, and we've seen like computers control it and stuff like that. But to actually make muscle fiber, to actually make what your body does naturally, we are so far down the road from that. But you need these breakthroughs to kind of get there. So we're so far, but at the same time, they're making amazing progress with research like this. So. Oh yeah, the buzzword here in this field, biohybrid.
Yeah.
Wow.
Exactly.
So freaky.
Yeah, to make it real. It's very, very cool. And hey, just one step closer to maybe, not just prosthetic, but replacement hands, feet, arms, fingers, whatever it may be. So one day, folks. Very, very cool. So, ladies and gentlemen, if you've been following along, because obviously by the time that you hear this, you'll be able to see the show notes up on the website, you may notice that there is even more. We're going to go ahead and wrap up today's show, because, we try to keep it to a more condensed form. But the honorable mentions are stories that simply we don't have time for. We do our 4 and we're good. But Ralph really likes to show off his prowess and say that, he finds even more cool stories. There's even more fun stuff out there if you look hard enough. Very, very cool stuff. So, Ralph, let's at least give the nice folks the headlines for the honorable mentions, and they can go to the show notes at computeramerica.com and check it out for themselves if they'd like.
Yeah, this one also is kind of medical related. It's from the Harvard School of Engineering press release. Headline: a tapeworm inspired tissue anchoring mechanism for medical devices. This is really a great story. It's kind of creepy. Creepy and gross, but great.
Yeah, the pictures are medieval look, torture device looking, but yeah, it has implications.
Yes, and it's actually a very seriously good story. Check it out. This one's a little more real. This brings us back to IKEA or Costco or wherever you buy furniture. And this comes from TechExplorer.com headline: Sofas that self-assemble when you heat them up. How 4D printing could transform manufacturing. And you might think, well, wait a minute, 3D, I get that. 4D? The fourth D is time. So you got to check this out. It's an intriguing story and a great article.
Very cool.
And then the next one from interestingengineering.com: world's largest electric ferry, boat, of course, uses battery power equivalent to 860 electric vehicles. That's pretty cool. And it's just another incremental step in the world of converting things that have been diesel to electrical power. And then our last one is from livescience.com. And the headline here is: artificial intelligence brain decoder can read a person's thoughts with just a quick brain scan and almost no training. Okay, police departments, this would be a good one for interrogation, right?
Yeah, let's hope it doesn't get to that. But you can imagine people who spend a lot of time train those models to look at a screen and predict their next word. Paraplegics and stuff, or total whatever. There are a lot of uses for it, not just by the police, but for a lot of people out there. So very, very cool story. And Ralph, you picked an amazing spread. I like that a lot. So, ladies and gentlemen, if you want to find out more, computeramerica.com. You'll find everything there. And ladies and gentlemen, until next week, I want to thank you so much for joining us and listening to us, giving us your time, and we will be back with more stories. So everyone, have fun. Do something fun. Have fun. We'll see you next time. Bye, everyone.